All right, welcome to the Explainer. So we're going to talk about something huge in AI today. How in the world do we keep it honest? Fair over the long haul. We're going to dive into some really cool research that looks at this whole problem in a new way, not as something you fix just once, but as a kind of continuous, a fair game.
And look, this quote really gets to the heart of it. The authors of the paper we're looking at say it perfectly. If you train an AI, say an AR recruiter, on old data, well, it's going to learn old biases. It's going to favor the majority and be less fair to minorities. Just imagine a hiring tool that starts preferring men just because that's what the historical data shows. And this isn't some sci-fi scenario, right? This is a real, core problem we've got to figure out.
Okay, so here's what we've got on tap. We'll kick things off with the unfairness problem in AI. Then, we'll look at why what we're doing now just isn't cutting it. After that, we'll get into this new idea, the fair game. We'll see how it's played, how it connects to the real world, and what roadblocks are still out there. Sound good? Let's jump in.
All right, first section, AI's unfairness problem. The really tricky thing here is that AI bias, it's usually not on purpose. Nobody's programming it to be unfair. It just sort of seeps in, when these systems learn from data that's already full of our own historical and societal baggage.
So to make this super clear, the paper gives us this great example. Let's pretend there's an AI tool called AR Recruiter. Simple enough, right? Its whole job is to help companies find the best people. It's meant to be fast, efficient, totally objective. But, and this is the big but, what happens when it's learning from our messy, biased human data?
And believe me, this AI Recruiter example isn't just some academic what-if. This stuff is happening right now. The source material points to some pretty big cases. Remember Amazon's hiring tool? It ended up showing bias against women. Or the Compass system, used in some U.S. courts, which turned out to be biased against defendants of color. Even things like SAT-based admissions have been called out for economic bias. So yeah, this is a really widespread problem with huge, real-life consequences.
Okay, so if we know this is a problem, what are we doing about it? And this, right here, is where we get to the paper's main point. The way we check for bias right now, it's kind of like trying to understand a whole movie by looking at just one single snapshot. It just doesn't work.
So how do we check for bias today? Well, the standard way is what's called a static audit. And it's pretty much what it sounds like. It's a one-time check, a spot check on the system to see how it's doing at that one moment in time.
And here's the fundamental problem with that. Static auditing, it's like taking a single photograph. It tells you if the AI was fair in that one frozen moment. But the real world, that's a continuous video, right? Society changes, the data changes, our own ideas about what's fair are constantly evolving. A single photo, a snapshot, it just gets outdated almost immediately. It can't keep up.
So this is where the paper proposes a really big shift in thinking. Instead of that one-time photograph, what if we had a system that could watch the entire video in real time? A whole new way to audit this constantly moving target. And this is what they call the fair game framework. The core idea is pretty brilliant, actually. It's a dynamic system where you have two key players, an auditor and a debiasing algorithm. And they're locked in this continuous game, back and forth, to keep the AI model fair as it goes along and changes over time.
Okay, so how does this game actually get played? What are the rules? Let's get into the nitty-gritty of how this whole thing works. It's actually a really elegant setup.
It's all built around this constant feedback loop. Think about it in 5 steps. Step 1, the AI, our AI recruiter for instance, makes a decision. Step 2, the auditor swoops in and checks that decision for any bias. Step 3, the auditor sends its feedback, its report card, over to the debiasing algorithm. Step 4, the debiasing algorithm takes that feedback and actually adjusts the AI model. And step 5, and this is the key, the whole loop just repeats over and over again. It's a system that's always learning, always adapting. I love this analogy they use, thinking of the two players as a referee and a coach. It makes so much sense. The auditor, that's your referee. It's watching the game, looking at what the AI model is doing, and if it sees something unfair, it blows the whistle and calls a foul. Then you have the debiasing algorithm. That's the coach. It gets the call from the ref, pulls the player, the AI model aside, and says, okay, here's what you did wrong. Let's adjust your strategy so you do better next time.
So what's the engine driving this whole game? It's a type of AI called reinforcement learning,
or RL for short. And RL is absolutely perfect for this job because that's what it does. It's designed to learn from a constant stream of feedback to get better and better at achieving a long-term goal. And in this case, that goal is long-term fairness.
Okay, this is a really powerful idea in theory. But does it hold up in the real world? Well, the paper gives us a perfect case study to look at. One of the very first laws ever passed to try and regulate AI in hiring.
So let's talk about New York City's Local Law 144. It was a really big deal, a pioneering attempt to get a handle on this stuff. It was passed in 2021 and went into effect in 2023. But here's the catch. Look at the main requirement. It calls for annual static bias audits. See what's happening here? This is that exact snapshot approach we were just talking about.
And according to this research, that created some real problems. For one, it was too simple, just using a single way to measure fairness. And because it's static, an annual checkup, there's no way it can keep up with how fast these AI models change. But here's the biggest thing. The law didn't really give a clear path for the AI to get better based on what the audit found. It's like it points out the problem, but doesn't offer a dynamic way to fix it. And that gap? That's exactly what the fair game framework is designed to fill.
Now, the authors are realists. They're not saying this is a solved problem. The fair game is a framework, an idea. It's not some off-the-shelf product you can just go buy. They're very clear that there are some major hurdles we still need to get over to make this a reality.
So here are the 5 big questions they lay out that researchers now need to tackle. 1. How can we audit these things without needing a mountain of data? 2. How do we stop companies from just gaming the system to pass the audit? 3. How do we design the right kind of reinforcement learning for the specific game? 4. How can we get more complex, more human-like feedback into the loop? And the big one, can this game ever reach a stable, fair point without just spinning out of control? Now, these aren't dead ends. This is the exciting stuff. This is the next frontier for this kind of research.
And that brings us to the final thought, and it's a really provocative one. The fair game, it gives us a way for AI to adapt to our rules of fairness. But here's the twist. Our own ethics, our social norms, they're always changing. We're constantly rewriting the rulebook. So the ultimate question the paper leaves us with is, well, it's a deep one. Can we really teach an AI to play fair in a game where we, the humans, are still trying to figure out the rules ourselves?